Logarithmic decrement method is practically used to determine the damping ratio of an underdamped system. First, we need to derive the formulation using the solution for displacement of an underdamped system subjected to free vibration. Let x1 and x2 represent the peak displacement in two consecutive cycles. The corresponding time is defined as t1 and t2 respectively. The value of x1 is greater than x2, while t2 is 1 period away from t1. By substituting the interested time and displacement into the solution for x, we produce two expressions. Then, we can express t2 as the sum of period and t1. Next, we apply trigonometric identity to transform the expression of x2 into favorable structure. Let's take the ratio of x1 to x2. From here, we can eliminate the trigonometric terms, and that ratio is now the exponent of damping ratio, natural frequency, and system period. We may further simplify this expression and eventually apply natural log to it. If you want to inspect across several cycles, we can first implement the following correlation. Going through the same process as we demonstrated previously, the number of cycles n is now considered. When the damping ratio is small, the expression may be reduced to the following approximate solution form. When the damping ratio is not negligible, we should not reduce the expression. Instead, we need to derive the exact solution from the full expression. Let's plot the result obtained from both exact and approximate solutions for multiple damping ratio to check the condition for approximate solution to be valid. From the graph, both curves coincide each other until the damping ratio of 30%. Divergence is observed when damping ratio is greater than 30%. Therefore, when the damping ratio of the system is less than 30%, we are good to implement approximate solution. Given a structure that shows initial displacement of 10 mm after 200 kN of lateral force is exerted on it, the mass carried by the system is 5 tons. How long does it take to reach 2 mm of lateral displacement if the damping ratio of the structure is 5%? First, let's solve for stiffness component using Hooke's law. Then, we can use mass and stiffness component as well as damping ratio to solve for both natural frequency and the frequency of damped system. Subsequently, we can determine the period of the system. Since the damping ratio is only 5%, we can apply approximate solution here. In this case, the number of cycles is the unknown that we need to calculate. Knowing the number of cycles from the initial state required for the system to exhibit 2 mm displacement, we can translate it into time required by multiplying the period of structure. Thank you for watching. If you find this video helpful, please share it with your friends. We will see you guys soon. Goodbye.